So looking at the review, this is the video for 11 through 20. Reminder that the final is 50 multiple choice questions. It's all no calculator, just like the review. And I mean, if you're reviewing other stuff, that means there are some questions we can't ask you. But so it's arguably easier because we can't ask you the crazy questions because you don't have a calculator. All right, number 11. Get the paper to fold right here. There we go. Yes, this is the video for 11 through 20. Which of the following is true? It's like, I don't know. I guess I'll have to FOIL and find out. So 1 times 2 is 2. 1 times 5i is 5i. Minus 6i. And then minus 15i squared. And the point is 15i squared. What's going on here? That becomes plus 15 because I squared is negative 1. So 2 plus 15 is 17. 5i minus 6i is negative I. And since I'm halfway right, I'm double checking, make sure I did that right. Yeah, so number 1 is not correct. Halfway correct, which is not correct. Statement number 2. 3 minus 2i squared. So 3 minus 2i times 3 minus 2i.
Do I need to take it outside?
Yeah, you can take it there. First outside, inside last. So 9 minus 6i minus 6i. And then that last one's always the tricky one, or the be careful one. Negative 2i times negative 2i would be a positive 4i squared. Which is negative 4. So 9 minus 4 is 5. Negative 6 is negative 12i. And you can see the mistake they made. 9 plus 4 is 13, but that's not what you're supposed to do. So 2 is out. And that gets us to number 3. 4 times 4. Outside would be minus 12i. Inside would be plus 12i. And last would be minus 9i squared. The I terms cancel. You might have recognized that from the get-go. When you multiply conjugates, the middle terms cancel, always. And then minus 9i squared is plus 9. 16 plus 9 is 25. So finally we got one that's right. 3 only. Number 12. Ooh, powers of I. So I is just I. What's I squared? Negative 1. We just did that. How about I cubed? Negative I, because that's multiplying those two together. And I to the 4th is 1. So that's a tricky way to test that you know those powers of I. So I minus 3 minus 5i plus 8. So I minus 5i is negative 4i. Negative 3 plus 8 is 5. Let's see, that's backwards from how the answer is written, but it's still the same thing as answer choice D. Factor that thing completely. Completely suggest there will be multiple steps. Always look for a GCF first, so I can take out the x. 27x cubed minus 64. Oh, that's a difference of cubes. So same, opposite, always positive for the signs. Soap. haven't used SOAP in a long time, and it really shows. Haha. We start with the cube root of each piece. So 3x. If I cube 3x, I get 27x cubed. The cube root of 64, well, especially if you start looking at your answer choices, that helps. Is 4. And don't forget the x out front. So it's looking like B or D here. What's going on with A and C? So let's see. We square the first term, multiply the two together, square the second term. So square the first term, we get 9x squared. Which again, this is matching up. That's where it's nice to have multiple choice. When we multiply the two together, we get 12x. And I'm not worried about that negative sign, right? Because SOAP takes care of the sign. So some people sort of overcompensate with the sign, like, aha, negative 4 times 3. Like, nope, SOAP takes care of the sign. And then we square 4, and we get 16. So the answer is D. That middle term was... I don't know where you get 24 from. Number 14. I haven't done one like this in a while. So I've done most of these in a while. G must be an even-degreed polynomial. What does it mean if it's even degree? Do you remember? The ends are doing the same thing. So like x squared, parabola, the ends are doing the same thing. X to the 4th, they're either both up or both down. So this thing is odd because the ends are doing opposite things. Opposite is odd. So statement 1 is false. A double root. So a double root, remember that's where it bounces off the x-axis somewhere. So does that graph have double roots anywhere? Yeah. In fact, it's got one there and one there. So that thing has 2 double roots. So statement 2 is false. Statement 3, the lead coefficient is positive. Uh-oh. My trusty orange pen is almost dead. Lead coefficient is positive, yes or no?
No.
Right. Lead coefficient is what the right end is doing. The right end is going down. So that's not true. So none of those are true. Number 15. The answer is already circled, but let's show the work to get there. Remainder. So how do I get the remainder? Why do I have to do long division? Why not synthetic division? Because it's squared in the bottom. So yes, long division. And I mean, synthetic division is shorter, but in some ways, long division to me is easier because it's just like long division in 3rd grade. So something times x squared gets me 3x cubed. Well, I need a 3, and I need another x, so 3x. And then we multiply it back, just like we did in 3rd grade, or 4th grade, or whenever we learned how to long divide. 3x cubed plus 3x. Remember, you want to keep your powers lined up so that things work neatly for you. And then, what do we do with 3x cubed and 3x? Minus them. Same thing we did in 3rd grade. Subtract them. That lead term should always cancel out, right? Because we picked the 3x to make those match. So that one goes away. 2x squared plus x plus 1. And then we repeat the process. Something times x squared gets me to 2x squared. So plus 2. 2x squared plus 2. And again, we subtract them. So minus 1. What does that mean? What do I do now? That is the remainder, right? Remember, you can be fancy and put x minus 1 over x squared plus 1, or you can just say, hey, the stuff left over at the bottom, that is the remainder. And so, yeah, 15 is x minus 1. Number 16. Uh-oh. What am I going to have to do to do number 16?
Oh, you're going to have to...
Common denominator. Yes, please don't just tell me it's 4x plus 2 over x plus... In fact, I bet I could mark out b right now. Like, that would just be they didn't get a common denominator. So 4x over x plus 3 plus 2 over x minus 3. Remember, this is the gripey kids in the back seat who want things to be fair when it comes to snack time on the road trips.
Yeah.
So first denominator says, hey, that's not fair. Denominator 2 has an x minus 3. Why can't I have one of those? All right, fine. Here's your x minus 3. Stop complaining. I know, this sounds like a very personal... This is, yes, real life in the Wolf family minivan. Well, then second denominator is like, well, that's not fair. He's got an x plus 3. Why can't I have an x plus 3? So we give the second guy an x plus 3. You're like, all right, everybody be quiet. Everyone, we're all good now. Because we have a common denominator. So 4x squared minus 12x plus 2x plus 6. And at that point, we probably start looking for our answer choices because I don't need to write anymore. 4x squared minus 10x plus 6. So I don't know where that minus 6x would have come from, but answer choice C. Definitely answer choice C. But the big deal was get a common denominator in order to add, or in number 17's case, subtract fractions. Once again, look at your answer choices for 17. One of those you can throw out almost right away. Probably C. Like, I really doubt we're going to get back to just 5 minus 3x. So I'm really doubting that C is right. 5 over x minus 4 minus 3x over x plus 2. We'll save the story time this time. We just know that they need a common denominator. In fact, I look at my answer choices and they all have the same common denominator, so I'm good there. I'm not even going to write that again. The numerator, 5x plus 10 minus 3x squared. Ooh, careful. What's the last term going to be? Positive. Negative 3 times positive 4 plus 12x. So let's see. That would be negative 3x squared plus 17x plus 10. So A. Number 18. Do I need to get a common denominator for number 18? No, I'm ready to just start canceling stuff out on number 18. Let's see. X plus 2 and one of the x plus 2s, so be careful there. X plus 3 and x plus 3 will go away. The 8 and the 24 becomes 1/3. The trick on this one is just being neat and keeping up with who's gone and who's left. What about x minus 1 cubed over x minus 1 squared? How does that cancel? How many of them can cancel? 2 of them. So all of the ones in the bottom and then 2 of the ones in the top. Okay, I'm going to rewrite this and see what's left. X minus 1 is left in the top. And I think that is it. In the bottom, there's a 3. Be careful, there's an X that's hiding right there. And then X plus 2. So X minus 1 over 3X and X plus 2. Answer choice A. Number 19, a hole. How do you, where does a hole happen? Do you remember? Well, you find it if the factor's in the top and the bottom. So there is a hole at X equals 3. The trouble is, you look at your answer choices, you're like, oh, they all have X equals 3. So how do I find the Y value? Plug in the X value. Plug it into what, I guess? All of it. Make sure you plug it into the canceled out part. Or, I guess, plug it in after you cancel them. If you don't, you'll end up with 0 over 0, and that's why there's a hole there. So after you cancel the X minus 3's, then we can plug in 3. See, 3 minus 2 is 1. 3 minus 1 is 2. 6 times 4 is 24. Over 2 is 12. So X is 3, Y is 12. Answer choice C. Number 20, x-intercepts. Let's factor everybody first. X plus 2, X minus 1. Surely everyone can factor at this point. Probably not true, but let's see. So we would need a 2x and a 2 to make the 4, and then minus, so 4x minus x is 3x, and everything else works. I'm looking for x-intercepts. What is x-intercept? How do I find an x-intercept? Well, always and forever, an x-intercept is where y is 0. So if we set this thing to 0, what makes a fraction 0, the top or the bottom? The top, right? Because if 0 is in the bottom, what do you get? We're undefined, that's right. But I need to be careful here. What about this x plus 2? What's going on there? They can cancel, so there's a hole at x equals negative 2. There is not an x-intercept. You can't be both. You're either a hole or an x-intercept. So it's a hole. So all those negative 2's are not right. And the only thing left that makes the top 0 is x equals 1. Do you remember what's going on at x equals 1/2? Something's going on down there. It makes the bottom 0, which you just told me was undefined. That's a vertical asymptote. You know, we said we were going to go through 20, but let's do 21 because it's right in that same unit of holes, asymptotes, vertical asymptotes, x-intercepts, all that stuff. So 21, which of the following functions has a hole when x equals 3? So that should mean we have an x minus 3 top and bottom, not an x plus 3 top and bottom. X minus 3 top and bottom. X minus 3 top and bottom. Okay, so we ruled out one. Vertical asymptotes, we were just talking about that. So x minus 2 in the bottom and x plus 5 in the bottom. So I need x minus 2 and x plus 5. D's got them backwards there. D's out. X minus 2 and x plus 5. Uh-oh, B and C both have x minus 2 and x plus 5 in the bottom. So what's going on here? C has a hole there because there's an x minus 2 in the top. So that's a hole. We didn't want a hole. We wanted it to be a vertical asymptote. So the answer is B. That one's kind of tricky until you realize there's a hole, top and bottom. All right, we'll stop there. Again, I'll post other videos for the other problems.